So I hope you guys were able to observe what part of the system rotates. So obviously armature rotates, right? In between the brush B1 and B2 and the ring rotates while the brush is fixed, right? So the next thing that we need to observe is I have the multimeter setup. I hope you guys observe that. So I have the multimeter setup to read the resistance of the system, like basically at this end and this end, instead of the positive and negative terminals, I connected it to the multimeter. So basically it's reading the resistance offered by the system. So in the coming video, I'm going to show you guys the values, right? You have to observe what is the reading. So in the multimeter, if you happen to read a value like 1 on the left extreme, that means infinite. Okay, whenever you see in multimeter, if it's 1, it means it's very high, higher than what the multimeter can read, basically. More than infinite, I should be telling you guys that it is higher than what it's able to read, basically. Okay, so I'm going to play the video. Please see that you understand where the rings are, right? If it's in contact with your brushes or not. So we need to make such observation. Okay, and just make a mental note of the reading. Okay, so that's your agenda. Okay, I hope you guys were able to do so. So when we saw the rings were in touch with the brushes, what happened? The value was a positive readable value, right? Around 200, 300. When it came in this way, I hope you guys observed that. When the coil came up and down, the value value was 1. That is something which very high value, high resistance. And in this case, it was again a positive value. In this case, it was of high resistance. Make sense? So why is that happening? Well, it's quite simple. In this case, the circuit is complete, right? The positive terminal, the current will flow in this way. So circuit is complete. So there is a flow, there is a path for the charges to move across. In this way, you can clearly see there is no path. It's like an open circuit. So obviously it is a high resistance. Now, open circuit is always high. And here it is positive again, and this here it is high again. So that's the basic funda. Okay. Now coming back to why do we need such a system? Why does all of this require ring and the brush, and why can't we just directly connect it to the battery? So let me explain the reason. We saw that using Fleming's left hand rule. I hope you guys remember because it's a continuation. We saw that this moved up and this moved down, right? So basically it's in clockwise. So I draw an arrow just to keep in track what is happening. So now the system moved a bit to the right. So clockwise. So basically the arrow is pointing downward now, making an angle of 90 degree. Make sense? So that's your brush 1. Brush 2, it stays wherever it is and is always connected to your positive and negative for this particular picture. So ABCD is oriented in this way. So ring 1 is at top and ring 2 is bottom, right? So, but there's no flow of current. Technically, there's no flow of current and it should not be moving, right? Does it make sense? It should not be moving. Why? Well, there's no flow of current. There's nothing pushing and all that. This is just a wire placed in a magnetic field. Technically, it should be so. But because of inertia, right? Inertia of rotation, actually. You know what's inertia, right? An object will continue to move until unless it's opposed by something. So this object will continue to rotate until unless opposed by something. So it's ideally the system has to be very free. So it will just continue to rotate. So if it continues to rotate in your clockwise direction, what will happen? End of it, it will flip. So basically you have your AB, CD in this manner. Okay. So you have the pointer in the other way, 180 degree. Right? It is flipped this much. So this is your brush 1. That's your brush 2. This is your ring 1 and this is your ring 2. Okay, it's turned to this extent. So again, this is where the brush and the ring will be understood properly. So how will the current flow? So current will flow, conventional current will be directed in this way, going up, coming down, and to the negative terminal. So magnetic field though will continue to be so in this way, right? What will happen? This will get pushed up and this will get pushed down. This will continue to rotate. Why will this get pushed up and why will this get pushed down? Is it not AB? We happen to see AB to be get pushed up over here. So why is it not getting pushed up over here? Quite simple. The current is oriented in that way. But how did that happen? I mean, here the current was going up, here it was coming down. Well, the ring flipped, one thing, but the brush remained where it is. So B1 happened to be there and the ring 2 happened to come to a place where ring 1 was there. So the connection that ring 2 got established a connection between the positive terminal while ring 1 got a connection bit with the negative terminal. So the current flipped, but Fleming's left hand rule does not talk about what part of the ring is where. It talks about what current we are looking at, what is the magnetic field, and how the force will be experienced by the coil. So this wire will experience upward force, this will experience downward force, and so this will continue. And the next 90 degree is a flip. And so it has flipped 270 degree. Okay. So this is brush 1, this is brush 2, this is ring 2, and this is ring 1. Right? And so because of again inertia of rotation. Okay, there is an inertia of rotation also. If something is rotating, it will keep rotating. Can you guys give an example? You guys are standing on it. Think about it. What is rotating? Okay, so let me know in the comment section. What do you guys feel is rotating? Now, what will happen because of inertia of rotation will continue and will come back to the same position what it started with, right? And this cycle will continue. So what is the role of your brushes and the rings? The brush will help us get the connection of the positive and negative terminal with the rings. The ring will keep the direction of the current in the same way. Basically, it will keep the direction of the current in clockwise in this case. See, if not, the whole system will not, this system will not rotate. If it goes half the way and if the direction flips, if B1 happens to be pushed up and this happens to push down, right? Does it make sense that it will get pushed up and this will get pushed down? When it rotates 180 degree, right? Let me give an example. Say there was no ring and everything, right? It was a direct connection, something. Let me erase this off. So there was no brush system, one thing. So entire whole thing moved, say it is so. So this is ring 1 and this is ring 2. Magnet is not moving. So this is north, this is south. And we have, and you guys don't question that, okay, sir, what if we move the magnet itself? Again, if you try to move entire thing, there's loss of energy. So it doesn't make sense that you are moving entire system. Okay. So that won't make sense in terms of energy. So it is flipped 180 degree, right? And say this happens to be connected to positive. It will continue to be connected to positive, and this continues to be connected to negative. What will happen? So current will go in this way and down over here. So this will get pushed up and this will get pushed down. So what happens? A coil which is turned in this way will start to get pushed in the opposite direction. So you guys can see what happens, right? Flip flop, right? It's like, how to tell, when you make your roti go in one flip and back, right? So that does not make sense. The motor can't go in that way. It has to go circular, is it not? Clockwise, if not anti-clockwise, but not flip flop. So that will not make sense. So the system will not make sense if you connect it this way, it's always connected to positive and this is always connected to negative, right? So current has to flow in one particular direction and this is how it works. Make sense, right? So this is the main role of the rings. So I'll revise at end. Armature helps in converting electrical energy to mechanical energy. Magnet it provides the magnetic field. Brush and the ring. Brush per se is connecting the terminals with the rings. The ring helps in keeping the current in one particular direction. Okay, right? So this you guys have to pause and write it off, all of it. And it's a lot, but you have to do it. Okay, so, oh yeah. Now again, I guess we'll observe the video once more so that you guys can appreciate what is exactly happening. So with a better understanding of where the rings are and all of that. So should make sense to you guys now.